All right, let's keep going with percent and talk about percent and change. So percents are used for comparing changes such as increases or decreases in sales, population, prices, and production. And if a quantity changes, its percent increase or percent decrease can be found using the following formula. So if you're looking for the percent of increase, you take the amount of increase and divide it by the original amount. Or if you're looking for the percent of decrease, this should say or, not of, if. You're going to find the amount of decrease, so like the dollar amount, we'll say if you're doing cost over the original amount. And then once you have that fraction, you're going to convert it to a percent. So what we're looking for here is the percent increase or percent decrease. So we're looking for a percent as an answer. Now, the thing you want to note here is you are always dividing by the original, and this is really important. This is something that gets mixed up often. When you're dividing, it has to be by the original amount. It doesn't matter whether the original amount is more or less, just it has to be the original amount in the denominator when you're dividing. All right, so let's look at an example. In 2000, world population was approximately 6 billion. And the figure here on the left shows the world population projections through the year 2150. The data are from the United Nations Family Planning Program and are based on optimistic or pessimistic expectations for successful control of human population growth. Okay, so you have 3 different projections here on what we think could happen with the population of the world and over the next, 150 years. Going from starting with 2000, right? So beginning in 2000 for about 150 years. So, and they have 3 different projections, right? Because we don't know exactly what's going to happen. So the top projection is looking at kind of a high count. So if population growth is really kind of climbing and staying on that kind of steady increase. You have a medium projection where population growth is still increasing, but just very slightly from year to year. So it's kind of slowing down. And then you have a low projection where we're saying that over time, so there's a little bit of growth here, but that population rate is decreasing over time. So, people are not having as many children theoretically in the future, right? So they have 3 different predictions for what could potentially happen. We want to find the percent increase in world population from 2000 to 2050 using the high projection data. So I'm looking for percent increase. So using that formula, I have the amount of increase. I'm going to divide that by the original amount. Now here we're focusing on the high projection. So in 2050, our total population they're expecting to be 30 billion. And then right now, starting in 2000, we are at 6 billion. So the amount of increase, you need to be careful here. It's not 30 billion. That's not the amount of increase. The amount of increase is the 30 billion minus whatever we're starting with, right? We already have 6 billion. So we need to subtract that out to see the actual change there. So you just want to be careful. So we're changing by 24 billion people. Now your denominator is always the original. So my denominator is going to be 6 here. And then I have 24 divided by 6, which is 4. Now remember, I want a percent here. So once you have your value, you want to go from that fraction to your percent. And we can do that by multiplying by 100. So I take that 4, I multiply it by 100. So you can just do that, or you can always move your decimal points 2 places to the right, and you get 400%. Okay. So our percent increase is 400% using that high projection. Find the percent decrease in the world population from 2000 to 2050 using that low projection. So same idea. So this time I'm starting with the 6 billion and I'm going to 4 billion. So that change there is 2, right? From 6 to 4, going down by 2. So I have a change of 2 in this case. And the original amount is 6. So this is the same as the fraction 1/3. And again, what we can do here, you can do it a few different ways. You can just multiply that fraction by 100. But that 1/3, what we can do a little bit easier is to make it that decimal first. Here, I didn't have to worry about that. But 1/3 is the same thing as 0.33333. So I just use my calculator. And then to multiply by 100, you're just moving the decimal point 2 spots to the right. So 33.3333%. And then we can round that. So maybe we say that it's about 33.3%. Now, the other way you could do that too, if you want to have a more accurate decimal here, is you could use a fraction here. So you could either recognize that this 0.3 repeating, it's a pretty common fraction, is 1/3. So this percent could also be expressed this way. Or another way to do it is when you have that 1/3 and you multiply it by 100 here to get your percent, this becomes 100/3. And if you remember how to convert over to a mixed number, see, this goes in 3 times. Sorry, that's a 1. Bring down to 0. And then 3 goes into 10 3 more times, which is a 1. So you get that same 33.1/3% that way. So just another way you could write an answer. Sometimes we'll leave answers in fraction form rather than decimal form. Here we have the rounded version. Here we have an exact version. So when you're converting to fractions, keep in mind that we're just multiplying by 100. So if you have a whole number, we can do that pretty quickly. If you have a fraction, what we've seen already is you can make it a decimal form, which tends to be easy for most people, and then multiply by 100 by moving that decimal 2 spots to the right. Or if you want to leave that fraction for a more accurate answer, you can still work with that fraction, skip this piece here, and multiply it by 100. And then you can convert to the mixed number. So that's a different way that you can express it. So one thing to note is a percent increase can absolutely be more than 100%, and we saw that right here. So percent increases can be more than 100%. When you have over 100%, then you have at least doubled, if not done more than that, to your original value. So here, this 400% means that the original value has become 4 times larger. You can see that 4 right here, right? 6 times 4 is 24. So you've increased by that factor of 4. Percent decrease though, unless you have negative quantities, which is a little bit different, should not exceed 100%. When you decrease a quantity by 100%, it is completely reduced to 0, right? So if you buy something at the store and someone says, oh, it's 100% off today, that means it's free. So you shouldn't have any percents more than 100 for a decrease, for amount of decrease. Again, unless you're allowing for negatives, that's a little bit different. But for most of our examples, we don't. All right, so there's our percent increase and our percent decrease. All right, a couple more examples. A jacket regularly sells for $135. Sorry about this typo, guys. I should say the sale price. The sale price is $60.70. Find the percent decrease of the sale price from the regular price. Okay, so we're looking for percent decrease. So our formula is amount of decrease over the original amount. So again, for that numerator, it's not just the decreased amount or the original amount, it's the change. So the amount of decrease is how much has it changed. So if we start at $135 and the price is now $60.75, If I subtract those two values, then I can get my change. So the price has changed by $74.25. Now, my original value here was 135. Okay. And what I get is 0.55. So that would be my answer in decimal form. And if I want it in percent form, I'm just going to multiply it by 100. So this becomes 55%. Okay, so that jacket was on sale for 55% off is basically what's happening here. Now, one thing I just want to clarify, typically if we say the word decrease, then you don't need a negative sign here. So I know some people are used to putting negatives for items that are going down or decreasing. So if I'm saying what is the percent of decrease or percent decrease, then you can just say, oh, the item decreased by 55%. By using that word decrease, it implies that the value is going down. So you do have this kind of negative flow. Sometimes we may say things like the percent change is negative 55%. So you may see sometimes wording like that. But again, they're not using the word decrease. They're just using the word change. So if I could say percent change is negative 55%. But once I use that word decrease, I don't need the negative anymore because it's implied. So that's why you're seeing that all these percents are positive here because we're using that word decrease. So if I say my percent decrease is 55%, that implies that we have a reduction there automatically. So you don't need an extra negative when we're talking about percent decrease. All right, so I want to look at a couple examples where people did things wrong. So this is a section called abuses of percent, and it's actually really easy to mess up percentages. So to do them incorrectly or to, whether it's on purpose or not, kind of unethically compute them so that they look to be more extreme than they really are. So you want to make sure you're computing percentages the correct way. So here's an example. John Tesh, while he was co-anchoring Entertainment Tonight, which is a show, reported that the PBS series The Civil War had an audience of 13% versus the usual 4% PBS audience. And he noted that this was an increase of more than 300%. So did he report the percent increase correctly or incorrectly? So let's figure it out. So our percent increase is the amount of increase, again, which is the change of over the original. Now, it gets kind of weird doing this when you have percents already, but we're still going to follow the same procedure. So the amount of increase, well, we had 13% and we started at 4% normally. So that's a change of 9%. And then here, our original value is 4%, right? Because it's usually 4%. So what happens is this 9 over 4, when I divide that, I get 2.25. And then I'm going to go ahead and move my decimal 2 spots to the right to multiply by 100. And I see that the percent increase is actually 225%, not 300%. Okay. So I think what happened with this calculation here is they said, well, 4 times 3 is 12, right? 4 times 3 is 12. So if we do 300%, that would be the same thing as multiplying something by 3, then that value is over 300%, right? Because 13% is more than 12%. So I think what they did is they just took that 3% and they multiplied it to get that new value of 13%. But what they have to do is actually subtract first. That numerator is not just the original value or the new value, it's the change. So we actually had a 9% change here. So when we divide by 4, we see it's actually a 225% increase rather than 300. All right, another example. So a politician states that if you elect me to office, I promise to cut your taxes for each of my first 3 years by 10% each year for a total reduction of 30%. Evaluate the accuracy of the politician's statements. So one thing to note is this is a very common mistake. And the same idea actually works with shopping if you have multiple discounts. So let's say an item says it's 50% off and then take an additional 30% off. It's not 80%, right? If it was 80%, they would say 80%, but it's not. So when you have these kind of escalating discounts or these changes, so this is a discount, right? Because we're reducing taxes, so we're discounting. So when you have these discounts that occur one after the other, it's not as simple as just adding all the percentages up. You actually do one discount at a time and see what happens. So I think the easiest way to do this is to just take an easy example. So let's say that a taxpayer paid $100 in taxes originally, so before this politician got elected. So in the first year, he's going to cut taxes by 10%, right? So I take my $100 that I usually spend, so my discount amount, and I multiply it by that percent off. So we're going to save 10%, or you can write it the other way, put the percent first. So I take that $100. Now 10%, make sure you put this in your decimal form. So you're multiplying by 0.10. And what you get here is $10. $10. So after the first year, instead of paying $100 in taxes with this new politician, you would actually pay 100 minus 10, which is $90 in taxes. So what I did here is I did a discount for 10%. Now for the second year, the taxpayer said he's going to take another 10% off. But keep in mind that your taxes are not $100 anymore, they're now $90. So our discount amount for that 10% is not based on $100 anymore, it's based on the $90. So what I have here is I'm multiplying that 0.10 times 90, and when you do that, you get $9 instead. So the taxes that they would pay this year would be $90 minus 9, which is $81. And then we're going to do the same thing again for year 3. So discount amount equals 10%. And again, this time our taxes are not 90, they're $81. When I multiply this out, I get 8.1. And remember, this is dollars, so this would be $8.10. So the taxes we pay here would be 81 minus $8.10. And when you subtract this out, they would pay $72.90. So this person is still seeing a good discount, right? So if this is someone that they're voting for because they really want to see their taxes discounted, then they're still seeing a nice discount here, right? They started with $100, and by the end of the 3 years, they're only paying $72.90. But is this 30%? And I'll tell you right now, it's not 30%. So let's see what the percent of decrease was. So it's going to be the amount of decrease over the original amount. Now, my amount of decrease here, we want to be careful. I started with $100 and we're now paying $72.90. My original amount was 100. And when I subtract this, I get 27.10 over 100. So dividing this out, I get 0.271. And if I put this in percent form, multiplying it back over, I see that my discount was actually 27.1% instead. So not quite that 30%. And again, this is a common mistake that a lot of people make when they see repeat discounts. They just kind of add all the percents together, but it doesn't work that way. And the reason it doesn't work that way is because every time you take a discount, your starting amount changes. So you're not taking the value off the same amount each time. So it's going to affect things. So here's a common mistake. And again, we tend to see this a lot with shopping. I know I always joke, my mother is like the best sales shopper in the world. And she's that type of person who can find the discounts that are, 50% off, take an additional 30% off, and then she's got like a 20% off coupon on top of that. So when you have those multiple discounts, you're doing this instead. They're not just adding all those percents together. They're doing the 50% first, then the 30, then the 20, so that, you're not getting that would be 100% right. You're not getting 100% off, but you're getting a lot off in the end.